This is Balkishan, lecturer in chemistry, Government Degree College, Siddipet. Today, our topic PERKIN reaction or PERKIN condensation. The statement of PERKIN condensation is aromatic aldehydes plus acid anhydride acid anhydride converts into the alpha beta aromatic acid, alpha beta aromatic acid in the presence of sodium or salt of carboxylic acid. This is the state. Aromatic aldehyde reacts with acid anhydride in the presence of salt of carboxylic acid to form alpha beta aromatic acid. For example, I am taking an aromatic aldehyde as a benzoaldehyde. This is the benzoaldehyde plus acid anhydride is this one. Acid anhydride, this one. This is called as acetic anhydride. Acetic anhydride is acid anhydride. This is the aromatic aldehyde. In the presence of this one only, salt of carboxylic acid of this acid only, sodium acetate is taken and hydrolysis, acidic hydrolysis to form this one. This one only. This is called as, this is the functional group alpha beta unsaturated carboxylic acid. Its name is cinnamic acid. So this is the statement. Okay, what is the statement? Aromatic aldehyde reacts with acid anhydride in the presence of salt of carboxylic acid of acid anhydride. Same I will explain, and form only alpha beta unsaturated aromatic, this one alpha beta unsaturated aromatic acid. Alpha beta unsaturated aromatic acid is obtained. This is called as PERKIN reaction or PERKIN condensation. In PERKIN condensation, some of the important points about the PERKIN condensation: only aromatic aldehydes are involved in this reaction, not the aliphatic. Aldehydes. This is the first point. Only aromatic are involved, aliphatic are not involved in this reaction. Now, the salt only, salt of carboxylic acid must be acid of anhydride. Acid of anhydride means only if we take acetic anhydride and we will take sodium acetate and here acetic, here sodium acetate. Only this is the acid of anhydride and ante, so this is the anhydride and here I am taking this anhydride. This anhydride when will form and when we take and so this acid, this is the acetic acid and acetic acid of 2 molecules and by the removing of water molecule will form anhydride. This anhydride is the derivative of acetic acid and acetic anhydride is the derivative of acetic acid and when we take an propanoic anhydride we want to take sodium propanoate and when we take here butanoic anhydride we want to take sodium butanoate and that's why salt of carboxylic acid must be acid of acid anhydride derivative అని చెప్పొచ్చు. Okay, must be acid anhydride parent acid and parent acid అంటే యాసిడ్ అనహైడ్రేట్ వచ్చినటువంటి యాసిడ్ పేరెంట్ యాసిడ్ అంటే ఇక్కడ అసిటిక్ అనహైడ్రేట్ అంటే వి వాంట్స్ టు టేక్ ఎసిటిక్ సోడియం ఎసిటేట్ అండి sodium acetate. Propanoic anhydride means sodium propanoate. That is the here point. And in this one only, one more point, a new CC bond will forms. Okay, tarvata, and the product is the final product. Final product is alpha beta unsaturated carboxylic acid, aromatic carboxylic acid. This is the some of the points and about the PERKIN condensation. Okay, na? In PERKIN condensation only aromatic aldehydes are involved and not the aliphatic aldehydes. Second point, salt of carboxylic acid must be the acid anhydride parent acid. Okay, the parent acid of acid anhydride. Tarvata a new CC bond is formed in this one. So this is carbon to carbon, a new CC bond will be formed. The final product is alpha beta unsaturated aromatic carboxylic acid in PERKIN condensation. Okay, I will explain the mechanism of this reaction. Here it is also nucleophilic addition reaction. It is also a nucleophilic addition. In the example, I given that example, and that example is benzoaldehyde is reacting with this one CH3 C double bond O and O C double bond O CH3 in the presence of sodium acetate and hydrolysis only. The final product is this one. Already I given explanation for this reaction. Here step 1 only, formation of nucleophile. Formation of nucleophile or carbene ion. So this step is similar to the aldol condensation. Okay, na? Now here sodium acetate and the sodium acetate which taken as a catalyst will give only CH3COO minus and Na plus. Okay, this CH3COO minus and now this is the CH3COO minus only. From that one, this is the base only. Okay, why? Because this one is acid and CH3COOH is the acid. When we remove one H plus ion and we obtain CH3COO minus. This is the acid and this is known as conjugate base. This is known as conjugate base because of here H plus ion difference from these two only. The acid base pair which differ by one proton called as conjugate acid base pairs. This one is acid and by removing of one proton we obtain CH3CO minus ion. For these two there is a one proton difference if it is acid then it is called as base. That's why acetate ion is the base. Acetate ion is the base. Now this acetate ion reacts with anhydride. This is the anhydride. Double bond O and O, C double bond O, CH3. So this is the anhydride. Acetic anhydride. Acetic anhydride. This acetic anhydride will produce a nucleophile. So this is the base and by shifting of this one, the H plus ion moves towards this one CH3COO minus. Okay, H plus ion is adding for this one. Here acetic acid will be eliminated. CH3COOH is eliminated. Then carbon ion is obtained minus double bond O, O, C double bond O, CH2, CH3. CH2 minus C double bond O, O, C double bond O, CH3. This is the carbon ion. Carbon ion acts as a nucleophile. Now step 2 only. Step 2. Attack of nucleophile. Attack of nucleophile or nucleophilic addition. Nucleophilic addition. Now this is the benzolidine. Benzolidine. Double bond O only plus carbon ion CH2 minus double bond O and O, C double bond O and CH3. By shifting of this one only, carbon gets positive charge, oxygen gets negative charge. This negatively charged oxygen, the positively charged carbon only, the negatively charged carbon attracts that. Therefore, a new CC bond will be produced in between the carbon to carbon. Already CH is present and O minus is present. Now new bond CH2. After that one C double bond O and O, C double bond O, CH3. This one. O minus this. Okay. After this one only, here step 4 only. Addition of proton. Addition of proton. Here this is the last one is the now reacting part only. CH2 C double bond O and O C double bond O CH3. This will take one proton only from acetic acid. From acetic acid. Already, so this is the acetic acid only. Acetic acid here removed only. Here giving one proton to this one. Then this will be obtained. Benzene ring CHOH. Okay, and CH2 C double bond O and O C double bond O CH3. this one అండి. ఓకే, నౌ స్టెప్ 5 అండి, లాస్ ఆఫ్ వాటర్ మాలిక్యూల్ అండి. Loss of water molecule. Okay, that one CH, OH, and I am writing H separately and CHH, CH2 only. Remaining is same one. Double bond O and O, C double bond O, CH3. So this will by the this one shifted to this side, this one shifted to this side. This reaction carried out at 100 degrees centigrade. At this 100 degrees centigrade, H plus OH minus eliminated as a water molecule. Then obtain this one, CH single here single bond. This OH is eliminated, but after this elimination of one hydrogen, there is a double bond. Double bond CH, double bond O, and OCH3. This is called as alpha beta unsaturated anhydride. Alpha beta unsaturated anhydride is the one of the final product. This final product, this is the step 1, this is the step 2, this is the step 3, and this one step 4. Now step 5 only, formation of product. Formation of product. Product or hydrolysis. Always you remember that any anhydride and on hydrolysis produces carboxylic acid. So this is the anhydride and that is the last part. Double bond CH and C double bond O and O, C double bond O, CH3. This is one C double bond here, CH3. Okay, this is the anhydride. Now it's on hydrolysis in acid medium. HOH. Hydrolysis is nothing but HOH. So from year to year bond will be broken. The byproduct is CH3, COOH is eliminated. CH3, COOH is eliminated. Then the main product is this one. Benzene ring, CH and CH. Okay, double bond. After this one, COOH. So this is cinnamic acid. Cinnamic acid. So this is the clear mechanism of PERKIN condensation or PERKIN reaction. In PERKIN reaction, step 1 is formation of carbene ion. This carbene ion is formed from the catalyst which we used, that one sodium acetate. Okay, the sodium acetate, the acetate ion acts as a base. It takes one proton and eliminated as a acetic acid. At that stage, due to the elimination of proton or H plus ion, it becomes as a carbene ion. This carbene ion acts as a nucleophile. That's why this nucleophile attacks the aromatic aldehyde, which called as benzaldehyde, intermediate, or this intermediate product is obtained. In this intermediate product there is a new carbon to carbon bond is produced and are formed. This intermediate product will take one proton present in the acetic acid, which eliminate in the first step and to form hydroxy anhydride, and that is beta hydroxy anhydride. This beta hydroxy anhydride will lose one water molecule at 800 degrees centigrade and forms alpha beta unsaturated anhydride. This alpha beta unsaturated anhydride on acidic hydrolysis converts into the alpha beta unsaturated carboxylic acid, which in this example the formed product is called as cinnamic acid. Okay, so this is the equation, mechanism and detailed explanation of PERKIN condensation. PERKIN condensation is very important reaction. This is completed. After this one, next to benzoin condensation. Benzoin condensation. Benzoin condensation. Here benzoin condensation is aromatic aldehyde and aldehyde. In this case also 2 molecules of aromatic aldehydes in the presence of potassium cyanide or sodium cyanide and converts into the beta hydroxy alpha hydroxy ketone. Alpha hydroxy ketone or aromatic ketone. Aromatic ketone. So this is called as benzoin condensation. This is called as benzoin. Not the scientist name and PERKIN condensation. PERKIN is the name of the scientist, but here benzoin is not the name of scientist and it is the name of the product name. Similar to aldol and aldol condensation, benzoin condensation. Benzoin is nothing but it is the alpha hydroxy aromatic ketone is known as benzoin. For example, I am taking benzaldehyde and this is the benzaldehyde. Benzaldehyde, aromatic aldehyde, 2 molecules only in the presence of potassium cyanide or sodium cyanide. Without potassium cyanide or sodium cyanide, this reaction will not take place. Here the main role of ion is only Cn minus. Cyanide ion is the main acting ion. Compulsory ion is the cyanide ion. What is the necessary? You will see in the mechanism. This is the product. OH and C double bond O and this one. This is called as benzoin. So this is the functional group only. This is the alpha carbon and this one hydroxy, that why alpha hydroxy. This is the aromatic ketone. So this is the example for the benzoin condensation. Benzaldehyde, aromatic aldehyde, 2 molecules condense into the alpha hydroxy aromatic ketone, which is called as benzoin, in the presence of potassium cyanide or sodium cyanide. Concentrate potassium cyanide or sodium cyanide is called as benzoin condensation. In benzoin condensation and cyanide ion produces aromatic carbene ion, which is stabilized by resonance. stabilized by resonance. Stabilized by resonance. This is one point. And here also new CC bond is obtained. The name of product is benzoine. These are the some points only. The important point one more, aliphatic only. Aliphatic aldehydes does not involved in the benzoine condensation. Okay, I will explain mechanism of this reaction. That is mechanism only. First I am writing the equation. This is the equation. 2 molecules of benzaldehyde with potassium cyanide giving benzoine. This is the equation only. This mechanism. Step 1 only. Attack of nucleophile. A nucleophile is the Cn minus. Attack of Cn minus. That is potassium cyanide is giving K plus and Cn minus. Okay, this will the first molecule of this one only. So this is the important step in this reaction only. C double bond OH. This is the first molecule of benzaldehyde. First molecule of benzaldehyde reacts with Cn minus only. Cn minus. This bond shifted to this side only, and this is attached to carbon. If bond shifted towards the oxygen, oxygen gets negative charge, carbon gets positive charge, and the positively charged carbon only attracts the negatively charged Cn minus ion to form an addition intermediate product. Here double bond, double bond, double bond, C, O minus and the H and the C triple bond N. Okay, cyanide is nothing but this is the triple bond. So here this one is stabilized by resonance. What happens only? This bond, due to the attraction of this one, cyanide is the morely attracted group only. This is the electron withdrawing group only. This electron withdrawing nature of Cn group only. Here there is a deficiency of electrons and yet carbon. That's why this carbon attracts the sigma bonded electron. So this one is attracted towards the carbon, and this H plus ion moves towards the oxygen due to the negative charge. At this stage only, this new structure is obtained. Bond, 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 and here already O. Now new bond with hydrogen. Here minus. Here C triple bond ion. Okay, so this is the carbene ion. This carbene ion acts as a nucleophile. Now this carbene ion stabilized by resonance. This one shifted to this side only. Now this shifted to this side only. Now this is the new resonance structure only. OH already present, double bond only, and C double bond N. So this type of resonance is not possible. Again, this can be shifted to this side only. That's why this carbene ion is the highly stable carbon ion. This phenomena is not possible in the aliphatic aldehydes. That's why aliphatic aldehydes does not involved in this reaction. Now the carbon ion, this is the first structure and this is the second structure. In step 2 only, step 2, nucleophilic addition. That is your first molecule completed and now this is the second molecule. Second molecule of benzaldehyde now reacts with carbon ion. Here minus OH, here C triple bond ion and benzene. Now this bond shifted to this side and this one is added to this one. Then this is the product. Bond and CHO minus O minus, new carbon to carbon bond and here OH and C triple bond ion. Here this one. Okay. After this one only, what happens only? Transfer of proton. Transfer of proton. H plus ion is transferred. So this bond shifted to this side only. Proton is added to this one. At that time only, this is the product only. Bond CH OH only. This is the OH and single bond. Here O minus. Here C triple bond ion and benzene. This now final product is this minus shifted to this side and the Cn minus which is initially added and will eliminate. This oxygen negative charge shifted in between the carbon to oxygen. Now the carbon to cyanide will remove that. Okay, at that stage only, this is the bond and CH OH only and C double bond O benzene ring. This one Cn minus. This is the benzoine only. Aromatic alpha hydroxy aromatic ketone. So this is the benzoin condensation. Benzoin condensation is nothing but conversion of aromatic aldehyde into alpha hydroxy ketone, aromatic ketone. This is benzoin condensation completed. After this one only, next reaction, iodoform reaction. Iodoform reaction or haloform reaction. Haloform reaction. Now, this iodoform or haloform reaction is this type of carbonyl compounds. The carbonyl compound may be aldehyde or ketone which contains 3 alpha hydrogens. Reacts with halogen like iodine. Iodine or chlorine or bromine. If iodine is formed, iodoform will form only. If chlorine, chloroform will form. I am taking iodine or X2 only. X may be chlorine, bromine or iodine. In the presence of base only, like NaOH, to form only, so this is CHX3 only. This is called as haloform. Haloform only. If iodine, it is the iodoform. Iodoform. If CHBr3, bromoform. Bromoform. If CHCl3, chloroform. This one only. The carbonyl compound, that is aldehyde or ketone, which contains at least 3 alpha hydrogens. Okay, for this type of, there must be, here if hydrogen only is the aldehyde, if here carbon only is the ketone only. Okay, to form this one, and the byproduct is H, C double bond O, bond only O, Na, salt of carboxylic acid. We will check which salt will form only. That depends upon this structure. Okay, its mechanism only. Step 1, formation of trihalo derivative. Trihalo derivative. Formation of trihalo derivative. Here H and H only. C double bond O. Here bond. Here maybe hydrogen, maybe R only. Okay. I am without giving any group only. First it reacts with halogen. Reacts with halogen. Here what happens only, before going to the this one, here what happens only, this one is eliminated only in the presence of base only. Here OH minus from NaOH only, it will give only carbon ion. This is also carbon ion reaction. With this carbon ion only, X and X, here X minus is eliminated only. Already here Na plus, here X minus, NaX is eliminated. Here Na plus is present, here X minus, here X plus is present. This plus is added to this one. Then we obtain only, so this is H, here X, and C double bond O is same. So this is the first molecule of halogen. This is first NaOH, first molecule of NaOH. Here also this first molecule. First molecule. In next step only, NaOH followed by halogen. This is the second molecule. Second molecule will give only this hydrogen is eliminated. X already present, now new X here and C double bond O. This is one. And third molecule NaOH followed by halogen. This is third molecule. Will give only H, X, X. Here H is replaced by halogen. So this is called as trihalo derivative. Trihalo derivative. This trihalo derivative only in step 2 will form haloform. Formation of haloform. Okay, this trihalo derivative only trihalo derivative is reacted with, this is the nucleophilic attack. This bond shifted to this side and the OH minus ion is added to this one. X and X and X already present and here O minus, here bond, here OH. After this one and so this is the important step and this bond shifted, the negative charge shifted in between the carbon and oxygen. That's why there is a carbon to carbon double bond and this one is eliminated. At this stage only, this is CX3 minus, okay, CXXX3 minus and plus only, here C double bond O bond OH is present. So this is the carboxylic acid. ఇక్కడ R పెట్టామనుకోండి ఏమవుతుంది RCOOH అండి. Okay, that's why this is the carboxylic acid. Acid means and it will give proton. Now the proton is transferred to this one. The final one is the CHX3. This is called as haloform. CHX3 plus and what will happen and here bond COO minus bond COO minus H plus is transferred from here to here and here COO. This COO minus will take and Na plus ion which present in the base and this is from the NaOH. Means Na plus OH minus. Na plus is more and to form salt of sodium, salt of carboxylic acid. Okay, that is the byproduct and so this is the main product is called as haloform. So this is the mechanism. That's why here why we require 3 alpha hydrogens means and these 3 alpha hydrogens are substituted by halogen. The first step is the substitution. Substitution of halogen at hydrogens. Hydrogen, 3 hydrogens are replacing by halogen atom. Okay, that's why formation of trihalogen derivative. First step is the substitution. Second step is the hydrolysis or addition. Okay, this is the addition, nucleophilic addition. After this one hydrolysis, we obtain chloroform or haloform. Okay, so this is the reaction. You must remember Andy, after this completion of mechanism, in this reaction Andy, the minimum condition of this reaction, the aldehyde or ketone which contains at least 3 alpha hydrogens. At least 3 alpha hydrogens will involve in the haloform reaction. I am taking some of examples only. Example 1. CH3 C double bond O H. This is called as acetaldehyde. Acetaldehyde. This is called acetaldehyde. Here 3 alpha hydrogens are present. C double bond O is present. Now this last one is hydrogen. That's why it involved in the haloform or haloform reaction. Second example, I am taking formaldehyde. Formaldehyde. Okay, in this formaldehyde there is no alpha carbon and alpha hydrogens also absent. Alpha hydrogens absent. That's why it is not involved in the haloform reaction. Okay, now one more. Taking CH3, CH2, CH4. This one. Okay, so this is the functional group. This is the alpha carbon. But here only 2 alpha hydrogens are present. Only 2 alpha. But our condition is 3 alpha. That's why this is also not involved in the haloform reaction. One more example. Fourth example. Benzoineide. benzolide. Here also no alpha hydrogens. That's why it is also not involved in the haloform reaction. One more example. This is acetone. Acetone. Here this is all functional group. Here alpha carbon. Here alpha carbon. Totally 6 alpha hydrogens are present, and that's why this is involved in the haloform reaction. Now total conclusion and in aldehydes and only acetaldehyde and only acetaldehyde in aldehydes, and in ketones and so this is called as methyl ketone antarani. This is called as methyl ketone involved in the haloform reaction. Involved in the haloform reaction. So this is the last conclusion. And one more important information from this equation is when we take iodine and in this reaction will form and iodoform. This iodoform is the yellow PPTL. Yellow PPTL. Okay. Iodoform is the yellow PPT. That's why based on this yellow PPT, we can distinguish some of the carbonyl compounds which involved in the iodoform reaction. The test is called as iodoform test. In some cases, how can you distinguish acetaldehyde from formaldehyde? That type of question will ask in your examinations. And how can you distinguish acetaldehyde from the formaldehyde? Here formaldehyde has no alpha hydrogens, and that's why it will not give any yellow precipitate with iodine and based on this reaction. But acetaldehyde will give yellow precipitate in this reaction. That's why based on this difference we can distinguish acetaldehyde from and formaldehyde or benzoldehyde or any other one. And okay, this is the test, and the name of this test is called as iodoform test, and this very important test. Okay, thank you. Today class is completed.